Thank you all for joining us. I know this is the last session, so for the day, we appreciate. We'll try and make it as entertaining as possible. There's only so much we can make this entertaining. Cool. My name is Karthik Lunkad. I am a product lead for all the .NET and Windows investments at Pivotal. Michael, you want to introduce yourself?
Yeah, hi everybody. I'm Michael. I'm the Director of Products at VMware. I'm responsible for the Windows ecosystem at VMware, as well as I'm the SIG chair for SIG Windows in Kubernetes community. So I'm responsible for some of the vision, direction, and functionality of Windows in Kubernetes.
Great. And today we're going to talk about Kubernetes in Windows at scale with Enterprise PKS. So once again, thank you for joining. If y'all want to come a little front, make it a little easier to have a more interactive session, you're welcome to. The volume is better, the sound is better as well. Before we get started, just want to get a sense of you all have people here used PaaS for Windows. Are there people working with that? All right, cool. See a good mix. Are there .NET developers or platform engineers? .NET developers? Cool, few. And some platform engineers as well. Awesome. And lastly, are there folks who've used Windows containers outside of PaaS? Ooh, nice. Fantastic.
Cool.
All right, just wanted to get a sense of the audience. So we have a nice mix here. So that's a great place to start. Just a safe harbor statement. I am a product manager, so I want to make sure the things I say are in the general direction, but not committed or any promises that we're making. I wanted to make sure that you all can take away three sort of key takeaways. As I said, last session, so if you remember anything from the session today, if you remember these three things, we'd be very happy. The first one is there's been a lot of evolution in the Windows container ecosystem. Linux containers have been around for a while. They've been around for about 10 or 11 years. But the Windows container ecosystem started with Microsoft launching Windows containers in 2016. But this is really a good time to start evaluating your .NET or Windows workloads and your portfolio about the different decisions around investing, migrating, or retiring. The second one is managing Windows worker nodes in PKS is mostly the same as Linux. Yes, that's true. We've gotten a lot of pains in making sure that the operational experience for managing Linux is almost at par at Windows. There will be certain differences, and there are differences between Linux and Windows. And then lastly, we're both standing here. You have folks in the audience as well. There are a lot of active investments that we are making across Pivotal and VMware for Windows support in Kubernetes and with the Pivotal platform. So there's lots of things happening, lots of things to enable easier migration stories, easier moving to the platform stories happening. So yeah, as I said, these three takeaways, if you can take away remembering this, that'll be a good win. Okay, so the clicker works. The agenda, we want to cover what are Windows containers. Some of you all know, some of you all may not. So I just want to give a quick, brief view of that. Why Windows containers? Why? A lot of people ask why. Why do I want to do Windows containers? A little bit insight into the ecosystem with the Windows and Kubernetes. Windows and PKS. What does that offering look like? And a little bit into the decision making between PaaS and PKS, invest or migrate. How do you make those decisions? More details on that in a session tomorrow with David and Chris.
And I want to make sure that you guys understand this. You're going to hear Pivotal Container Service, VMware Enterprise PKS or PKS. It's one product. VMware and Pivotal work together. We co-develop that product. It's just branded a little bit differently depending on if you buy it from Pivotal or from VMware. In a few months, when hopefully you're one company, that's no longer going to be the case. But for now, don't be alarmed. It's all one product.
Thank you. All right, so just going into the Windows containers and why. Just a quick background on how that evolution has happened. One of the first things in 2016, Microsoft introduced Windows containers. Fun fact, PaaS Windows had support for Windows containers with 2012 R2 before Windows 20 containers existed. It was using a framework called Ironframe that we had developed the container like framework. Moving forward, we PaaS Windows, a Pivotal application service for Windows, introduced the Windows container support with 1709. We went with, if you know a little bit about sort of the operating systems and how Microsoft ships the long-term channel and a semi-annual channel, Microsoft started shipping newer operating systems at a faster rate with the semi-annual channel so that they could iterate more features into the Windows container ecosystem. So we launched with 1709 because 2016 was not good enough for the platform. And we've been on a journey since. There was a Windows Server 2019 launch. We iterated it through a few operating systems. We went to 1803. We're finally sticking to Windows Server 2019. So that's been with 2.5. The open source community went GA in the Kubernetes land with the Windows functionality, also using Windows Server 2019. And finally, in August 2019, we launched PKS with the Windows support in it. So just wanted to give you how that's evolved. It's really, if you look at it, it's about 3 years. Whereas for the Linux community, it's been way longer. So it's amazing how fast the Windows container community has moved forward in building support for it. Cool. You want to talk about what are Windows containers?
Yeah, absolutely. So there's a couple of different nuances around Windows containers, and I want to make sure that we kind of set the stage for both the capabilities as well as some of their features and functionality. So if you think about Windows containers at the Microsoft ecosystem, there's kind of two types. The first one is the process-isolated containers. These are very similar to what the Linux containers offer today, where both the host as well as all the containers share the same kernel, both with each other, each container with each other, as well as the container and the host. And that's the type of containers that we're going to be using in PKS, as well as in the Windows support for PaaS in Pivotal. The second type of containers that Microsoft supports is what they call Hyper-V isolated containers. And these are very similar to things like Firecracker and Kata containers in Linux. This is where the container is running almost in a virtual machine. It has an isolated kernel, so each container has isolation from each other, as well as from the host itself. In the Windows ecosystem, that requires the Hyper-V to be enabled at the host OS, because it's really running almost like a virtual machine. So that's an important caveat. Today, both the Kubernetes community as well as PKS doesn't fully support them for production workloads. We are working to enable that through some functionality that's called Containerd, but that's an ongoing effort and likely will not see production level support for another 6 months or so. The important thing around Hyper-V isolation is, what if you had a multi-tenant environment and you wanted to offer containers across multiple different actors? Well, in PKS land, we actually offer a different way that you can enable this. We have made it so simple for you to create different clusters, whether they're Linux clusters or Windows clusters, where you can actually separate your different tenants that require a different level of isolation into separate clusters. And then you depend into vSphere or whatever your infrastructure as a service provider is to offer you isolation at the virtual machine or IaaS level. Now, in addition to the different types of Windows container isolation, there's also different SKUs that Microsoft creates that basically define the different Windows container images that you can actually use. The first one is NanoServer. That's basically purpose-built for cloud-native workloads. That's the leanest and meanest version of the Windows operating system out there. It really supports only .NET Core, and it is compatible with PKS. So that's, if you're building .NET Core applications, you should use the NanoServer image. It's fast, it boots fast, it's small footprint, and you're able to kind of minimize the amount of storage that's used in your cluster. The second type of image is Windows Server Core. This is really for applications that require the full .NET ecosystem and stack. So for example, if you have a WCF service or application, or if you have dependencies into certain drivers or other Windows APIs, and you need the full Windows ecosystem, you get Windows Server Core. That's also compatible in both PassW as well as PKS. And the last image, and this was introduced with Windows Server 2019, is the full-blown Windows Server image. That's really, I haven't seen a lot of use cases for it, but if you're writing an application that depends on GDI and is using web forms and some other type of graphical interfaces in your ASP.NET app, for example, then you're going to need full Windows Server.
Yeah, you really see the Windows Server Core containers, the most popular ones around migrating your .NET applications. So. But yeah, there are a lot of scenarios for using Nano Server as well.
Absolutely. So if you have an IIS-based app and you want to migrate it from an older version of the OS, very likely Windows Server Core is where you're going to land it, unless it's compatible with .NET Core.
Yeah. Then you might take it to Linux as well, and that's okay. Cool. Yeah, just wanted to talk about the why. Why Windows containers and why in the Kubernetes ecosystem. The end of support for 2008. That's been one of the key things that has happened this year, or at least it's upcoming with, I think it's in January 2020. This is a big milestone. There's a lot of Windows Server 2008 based workloads running across the world. Well, maybe we'll ask you.
Let's ask them. So how many of you guys have a significant number of workloads running on Server 2008 or 08 R2 right now? Okay. Few of you. Okay. We can help you with that.
Yeah, and I think that's interesting because that brings at a good point to evaluate like what do you do with those? Whether you continue to invest in them, whether you continue to migrate it or retire those workloads. The other thing is we have seen the Windows containers being used in PaaS, and we have seen that .NET app workloads run well in Windows containers. So we have more confidence that that's a good platform to use in production for your .NET workloads across PaaS and PKS. Leveraging your investment in Kubernetes, that's the direction that the community is going in general, and the Windows as well, Windows with Kubernetes as well. So you want to invest in a single set of tooling and single set of skill set. That's essentially where the direction is. The other things are around the opportunity to streamline your cloud migration strategy. You're either lift or shift your workloads or you're migrating workloads. You want to be using a single platform for enabling both of those. And finally, there are operational efficiencies that you're getting to manage all of your legacy workloads in a single platform. Oops. All right, cool. So the next piece is just talking about the Windows and Kubernetes ecosystem.
Absolutely. So from an ecosystem standpoint, like Kartik mentioned earlier, we kind of started late. But we're able to kind of rally the community and kind of show them what's possible and get them to start putting more and more investments into Windows. Now, we're not up to par in terms of our investments with the Linux ecosystem, but we're catching up fairly soon. So today, what are some of the things that you're capable to do with Windows containers on Kubernetes? You have Flannel overlay support. You also have Flannel host gateway support as well. From a networking standpoint, there's also a few other solutions like OVN OVS is possible to use on Windows, as well as the Calico networking solution is available on Windows. We have beta support for GMSA in Kubernetes 1.16. GMSA stands for Group Managed Service Accounts. Think of this as a way to give a Windows workload or a Windows container an identity in the Active Directory network. So this is very useful, especially in legacy applications that some of you guys have, because if you run any IIS website, it's very likely the application pools or even the identity is really tied to AD. So how do you take that workload and run it inside a container? And more importantly, what if your middleware, your web app that you're running in IIS needs to access a file server or a database, and that's also authenticated using Active Directory. So using GMSA will allow the container to carry an identity on the network and enable it to talk to other components within your infrastructure. Like Kartik mentioned, 1.14, we have stable release of Windows in Kubernetes, and that's built on top of Windows Server 2019. Now, we're actually adding support for 1903, which was the release of Windows that came out maybe 4 or 5 months ago, and you're gonna see that in the next release of Kubernetes. And there's a couple of alpha support capabilities. The first one is kubeadm. How many of you guys saw the presentation by Kenny about an hour ago in the same room here? Okay, so if you paid attention, kubeadm is kind of this bootstrap tool that enables you to kind of stand up a cluster. It's really one of the easiest and the most supported by the community tool to stand up a cluster. So it was natural for us to go work with that community and allow Windows nodes to join a cluster through kubeadm. So what we delivered was both that capability as well as a set of scripts that allow you to prepare a node so they can be joined using kubeadm. And then the last thing, and Kenny kind of alluded to that earlier in the previous conversation as well, is storage is a huge, huge area in Kubernetes, and it's going through a lot of changes with the out of tree and in tree drivers. So Windows is kind of getting a small part into that momentum, and through that we have introduced support for the container storage interface, so you can start taking advantage of your storage ecosystem for Windows as well. Think of this everything from the vSphere plugins and the vSphere compatible storage components to any other storage driver, especially the ones that the public cloud providers are enabling. So moving forward, the community will not stopping. So we want to continue down the path of this investment that we're making into making Windows a first-class citizen in Kubernetes. We're going to work on this capability called Containerd. Think of this as another daemon for running your containers that enables us to add a lot of other pluggable functionality. So with Containerd, we'll be able to do Hyper-V isolation. We'll be able to stand up Windows containers faster with more security and more pluggable capabilities around the bigger Kubernetes ecosystem. We're also going to continue advancing kubeadm so that in the future, we're going to enable cluster API support. And cluster API is what basically sits on top of kubeadm to take care of everything from infrastructure provisioning to lifecycle management and control of your Kubernetes environment. We're going to continue our advancements in GMSA, so we can take that to stable. So you'll be able to give your workloads a Windows identity and be able to do it in a production environment. And obviously, we're going to continue advancing CNIs, CSIs, and all these different pluggable components, whether they're in tree or out of tree. And last but not least is Envoy support. A lot of you guys, as you're maturing your Windows workloads, you're going to come to a point where you're going to need something like a service mesh. And Istio and Envoy are big players into that ecosystem. So it was important for us to make sure that we have Windows support for Envoy, so you'll be able to take advantage of a service mesh on Windows as well. So that work is in the early stages, but it's ongoing, and we're continuing to invest in it.
Awesome. Great, so that was more on the Windows and Kubernetes open source ecosystem. What does that mean for the Windows and PKS? If y'all haven't seen this before, PKS is a runtime for containers, but I've made it Windows containers. The key things here are that we want to try and bring the operational benefits of running Linux containers to Windows containers as well. So some of the things here you're seeing built with open source Kubernetes, this is very much true for Windows as well. It takes the Kubernetes open source releases and adds that to PKS. The other interesting things are the zero downtime upgrades. Again, these are same capabilities that we have had with BOSH in PaaS and continue to have that in the PKS land for Windows as well, right? So those are key investments that you'll see going forward are to enable all the integrations that you get with PKS, enable them for the Windows work as well.
So one thing I want to make sure that you guys get from these slides that's super important is If you do Kubernetes the do-it-yourself way, then you're using kubeadm, you have to figure out storage, networking, you have to figure out how to stand up your nodes. All of that is complicated, right? The fact that Kubernetes is infinitely customizable, it also adds a lot of complexity from an end user perspective. PKS eliminates all of that. It's a turnkey solution that's fairly opinionated. It gives you a standardized way to deploy a cluster with a lot of the different components that you see on that screen. So when you're standing up a cluster on PKS, you basically issue a command, PKS create cluster, you give it how many nodes and a plan, and boom, it's ready like 20, 30 minutes later. That's a level of automation and customization and flexibility and simplicity that you don't really get from a DIY Kubernetes. kubeadm is not used here. You use Bosch for your lifecycle management. You use NSXT and Flannel as your networking layer, and we just make things fairly simple.
Yeah, and as you'll see, if the slide changes, the workflow for creating clusters, as Michael mentioned, is the PKS CLI using the PKS API. And a lot of the work that you would have typically done to create Linux clusters is define a plan in the PKS style and use that to create a cluster. That's the same workflow for Windows support. That's why you would see a lot of times you're calling it Windows in PKS. The reason is it's not a separate tile. It's the same PKS tile that supports Windows workers. So when you enable a Windows plan, what you'll get is a cluster with Windows workers in it. Some of the other components as part of the cluster, the master continues to be a Linux-based master, right? So that's the key differences we have done is that your control plane, your Bosch, those are aspects that continue to be the same for PKS for both Windows and Linux. So just wanted to call out, this is the 1.5 release. This is what came out about a month ago. The first Windows support is for vSphere. Flannel is the networking mode available right now. As we said earlier, supports Windows Server 2019 and Kubernetes 1.14. Single stem cells for both PAS and PKS. That was one of the things we really wanted to ensure that the teams maintaining or operating the Windows stem cells with PAS continue to be able to use the same stem cells for PKS as well. So that remains consistent across the platform. In addition to as I said earlier, Windows support in PKS and not a PKS Windows. And these are all the investments that we are making in enabling all the integrations that we were talking about earlier. Some of the key things right now we're focused on is Windows with PKS, getting that to a GA state. We're making investments in making the integrated Windows auth story possible with PKS. Windows with build service, NSXT with Windows and Kubernetes. There's a lot going on. This is across Pivotal, across various teams in R&D and VMware that we're working to make this happen. Some of the key things you can look out here is the Windows in PAS and Kates. That continues to be a key investment to us. Envoy support, as Michael mentioned, Envoy support is happening across Pivotal and the open source community and Microsoft. So there's a lot of collaboration there going on. And finally, there's some work around the persistent disk as well as the logs and metrics things. And the biggest one to call out is the NSXT support for Windows.
So, and you're going to hear a lot of vendors talk about Windows support. There's actually a couple of announcements that came out with some of them announcing that. But I want to make something, for you guys to know is, as VMware and Pivotal together, we're the number 2, number 3 contributor to Kubernetes. So we put our money where our mouth is. We have made tremendous investments in Kubernetes. And then we together as Pivotal and VMware have also a leadership position in the Windows ecosystem in Kubernetes. So I'm the chair of SIG Windows, and one of our technical leads is a Pivotal employee. So we're actually heavily contributing into the open source upstream community and then taking all those capabilities and building them into our products. So we are actually in a unique spot to get the user voice from you guys and go translate that into features that we're going to come back and deliver to you through our different commercial products.
Right, so this is the last aspect. I'm going to touch on this a little bit about how do we enable sort of the decision making between PAS or PKS. I think I think this is really key. You have different abstractions for the different kinds of workloads you're going to have. You're going to have workloads that you want to continue to invest in, continue to improve. They may require investments at the serverless or application platform layer. There are certain workloads that are legacy workloads that you want to just make sure to maintain and not really continue to develop and continue to work. You can use the container orchestrator, and that's where sort of, depending on the kind of workload and the technical and business key aspects, you're going to make those decisions about whether you want to move those workloads to the PKS level or use PaaS for those workloads. What we have seen with across customers is the portfolio of .NET workloads are across a variety of landscape. Some of the things are in the greenfield territory, and that is .NET Core. Previously, this slide used to say .NET Core is the future. I've changed that to .NET Core future is here. The .NET Core ecosystem is very much here, and that is where a lot of the new development is happening, and that's the direction that should be gone in. The tricky thing comes when you start to get into sort of the modernize and legacy lift and shift. A lot of the things that you want to invest in, continue to modernize, you want to try and transform them to a cloud-friendly state. These might be IaaS-based apps. These might be some of the Windows technologies. These might allow have more flexibility to sort of assess the modernization patterns for it. The biggest chunk comes in the sort of the maintain category for where you're assessing whether you want to lift and shift. This is where some of the big patterns which Windows, especially .NET Framework applications have, things like the GAC, which is the Global Assembly Cache, Complus assemblies, the registry. These is where you're really getting to the meat of some of the .NET Framework apps. This is where PKS is really powerful. It really gives you that mechanism of being able to migrate those applications without writing a lot of code. And finally, there's the category of divest, is probably just kill them.
Yeah, turn them off for a week and see if anybody asks for that workload. Yeah. That works very well. But it's important to know that both VMware as well as Pivotal have a lot of assets that can help you evaluate your portfolio and figure out how to bucketize your different workloads, both using the principles in the previous diagram that you start from the higher level of abstractions down to the lower, as well as figure out which one of them are good candidates for modernizing into containers or modernizing into PaaS.
So these are some of the additional tips. Think about sort of what if they are using sort of really old .NET Framework dependencies, if the application has specific environment needs, specific drivers, specific agents that need to be installed with administrative access. If the application development team would like to manage the entire container image creation and lifecycle, that's really key. I think with PaaS, you sort of have that managed base container file system from Pivotal, but with PKS, you're now handing that over. The contract with PKS is you'll have the cluster created and make sure that it's up and running, but the actual workloads and the deployment lifecycle of it is something that you'll own. So that is a key consideration to assess whether you want to own that complete lifecycle of the creation of the image as well as the deployment of it. And finally, if you don't have the source code for things, you can create Docker files with just having just the actual application binaries. You don't need to have access to their source code. So if any of these apply, it's probably a good idea to use PKS for your workloads. And this was a primer. A lot more in the session tomorrow with David Duroff and Chris Humble talking about where they talk about different patterns and how to bring the .NET workloads in the Kubernetes world, starting from scratch with a live demo, maybe.
Yeah, and these guys also had a webinar on the 19th of September that kind of became the primer for this talk. So highly encourage you, if you're looking at modernizing Windows workloads, view the webinar, attend the session tomorrow. Combination of the two should give you a lot of the tool set as well as the knowledge to get started.
Again, just want to make sure to reiterate these takeaways. It's a good time to assess how do you want to move forward with your workloads. Managing Windows VMs and PKS is similar to Linux, and a lot of investments across Pivotal and VMware.
Cool. And I know we're out of time, but we'll probably hang around for questions. So if you guys have any Q&A, please, you can send us an email, find us on Twitter, or stay after this, and we'll be able to answer your questions.
Thank you.
Thank you.